Good evening, everyone on YouTube. This is Cathexis, and once again, I have Quantumeraser with us. Tonight, we are going to be laying the groundwork for some future episodes of cosmology. We're kind of going to be getting deeper into what the modern understanding of all of this is. But before we get to that larger conversation, we do need to kind of establish some ground rules, so to speak. So tonight we're going to be talking about the speed of light, and we're going to be talking about the CMB, also known as the cosmic microwave background. Now, just a quick recap of what that is they, well, it's allegedly a remnant from the Big Bang. So I'll read from Wikipedia here to give you an idea of what we're going to be talking about. The cosmic microwave background is the thermal radiation left over from the time of recombination in Big Bang cosmology. In older literature, the CMB is also variously known as cosmic microwave background radiation, CMBR, or relic radiation. The CMB is a cosmic background radiation that is fundamental to observational cosmology because it is the oldest light in the universe, dating to the epoch of recombination. Wow, that actually sounds like a creation story, like you would read in a Bible or a book. The epoch of recombination, I gotta look into that. With a traditional optical telescope, the space between stars and galaxies, the background, is completely dark. However, a sufficiently sensitive radio telescope shows a faint background glow, almost isotropic, that is not associated with any star, galaxy, or other object. This glow is strongest in the microwave region of the radio spectrum. The accidental discovery of the CMB in 1964 by American radio astronomer Arno Penzias and Robert Wilson was the culmination of a work initiated in the 1940s and earned the discoverers the 1978 Nobel Prize. So this is essentially what we'll be talking about. Is apparently there's this almost isotropic glow that is in the black, the darkest spaces in between the stars. Now, who knows? They might be looking at a ceiling. Anyways, I just wanted to get that out of the way. I'm going to introduce my guest, John. How are you doing tonight, brother?
Doing fine, sir.
That's good. That's good. Yeah, I didn't want to get too deep into this. We're just going to cover a couple technical aspects about the equipment used to measure this with the WMAP satellites. Now, I don't know if anybody else is aware, there's a movie called The Principle, which I absolutely recommend every person to see. It is it's a geocentrist point of view, yet they go through and point out that the WMAP information about the cosmic microwave background is pointing to what we've probably heard in this community, the axis of evil. And what that means is that we are the center, essentially, of all that we can see and understand about the cosmos around us. And this is a huge problem for heliocentrists, huge problem for Big Bang cosmology. And they are trying to sweep it under the rug. Now, where I think John's going to go with this, though, is we're going to question the validity of those satellites themselves. I mean, one of them was apparently 1.5 million miles away in a Lagrange point. Another one was, I think, 900 kilometers up. So that aside, we won't get into that, but there are other technical issues here that we're definitely going to cover. So without further ado, go ahead, John. We'll get into the presentations, and then afterwards, hopefully, we'll have a good conversation about this.
All right, sir. Well, before we get to the cosmic microwave background radiation, let's touch upon this this light years concept. There's a lot of confusion around there. People throw this term around also, light years, speed of light. So let's go ahead and try to iron this out. So light years is not a measure of time, it's one of distance. For you to be able to ascertain the time component, you must know the one-way speed of light. Unfortunately, you can never know that because it's a begging the question fallacy in total, resulting from the inability to synchronize two clocks by some distance. I'll show you. So how do we determine the speed or the rate of something? Everyone knows this. It's the distance equals rate times time, right? So rate is distance per unit time. It's the T that's in focus here. So you need two clocks, right? So clock A, terminus ad quo, and clock B, terminus ad quem. So you need a start point and an end point. But according to Einstein's relativity, the moment you move clock B, that clock is desynchronized. What do you need to know to reconcile and synchronize clock B to clock A? That's right, folks. You need to know the one-way speed of light. The very thing that you're trying to find, you need to know to synchronize or to square away the method that you're trying to find. The entire exercise is a textbook begging the question fallacy. Einstein made the very same conclusions. In the Special and General Theory, Relativity, the translation by R.W. Lawson, it would thus appear as though we were moving here in a logical circle. Regarding the one-way speed of light, he concluded that light requires the same time to traverse the path A to M as for the path B to M is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. Over. Therefore, the speed of light is the average two-way speed. It's merely a convention that we've agreed upon, and that's it. Now, for those who don't follow Einstein, third graders and above, more strikingly, as I talked about in my quantum mechanics presentation, according to quantum mechanics, independent of knowledge or the existence of the which path information, light, that is photons, have no defined properties or location. Photons exist in a state of a wave function. That's not a physical wave, which is a series of potentialities rather than actual objects. That is, matter and photons don't exist as a wave of energy prior to observation, but as a wave of potentiality. And we talked about this before with Professor John Wheeler. It begins to look as we ourselves, by our last-minute decision, have an influence on what a photon will do when it has already accomplished most of its doing. We have to say that we ourselves have an undeniable part in what we have always called the past. The past is not really the past until it has been registered. Or, to put it another way, the past has no meaning or existence unless it exists as a record in the present. Very important, that record there. So, unless you can explicitly identify the knower at the source of this light, photons, all these stars everyone's talking about in starlight, who also observed its entire path, and the observer who first identified it here on Earth and recorded it, remember the recording right here, he had to record it, date and timestamp. If you don't have that, then you're going to have to provide the speed for a wave of potentialities. Go ahead. I'll get the popcorn for that one. Not going to be able to do it. Oh, so that, I put that PS in here so I wouldn't forget. So I can just picture people trying to do this. So when you sit down and you're, let's say you're sitting down at your, going to read your favorite book, sit in your comfortable chair, and you have a light there. So you turn on that light. What I'm telling you here is that between the source of that light and the book, your hand, pants, chair, bed, whatever it is that's in that room that you know the path information for, that there is absolutely nothing between that source of light and the detector. That is your hand, the book, the chair, your pants. So I can just picture people, and I've seen people try to do this when I told them that. They'll just sit there and they'll put their hand up and try to see if there's anything there. I know you guys are going to do it. I'm telling you, there's nothing there. That light doesn't travel as we think it does. And that's what quantum mechanics has been telling us for better than 100 years.
Absolutely. I've even heard along the lines that it just is. It just, the moment it turns on and the moment that it hits the book is the same. See, so what are they clocked it at? They're trying to claim, what is it, 186,000 something miles per second? Is that what the official speed of light is?
Yeah, if I'm not mistaken. I'm sorry. I didn't
let me see. No, we're just talking about. That's a weird
Is it
way of putting it.
186,000 meters per second?
I'll find it real quick. Yeah, 186,282 meters per second.
Yeah, that's it.
Now, another thing that a lot of people need to realize is that the speed of light has changed over time. Now, the more the more scientism believers around us, they will tend to say that that's because we've gotten better measuring techniques. But these are considered constants. Their math is based on these constants. So if anybody hasn't gone down this path, and this is a slight divergence from what you're talking about, John, but everybody needs to go check out, and I mentioned it before, oh goodness, the banned TED Talk by Rupert Sheldrake. He has a whole 5-minute bit about the constants that have changed. Light, the speed of light has changed on numerous occasions. So his big G, they're using averages is essentially what it comes down to in their particular. I think there's a field that they use to a field of science that measures all the constants and keeps them in order, but they don't like to admit. He actually says they call it intellectual phase locking by them not admitting what it is. But anyways, so the point is, it is. Well, actually, let me read this from the speed of light. It says, Ole Romer first demonstrated in 1676 that light travels at a finite speed as opposed to instantaneously by studying the apparent motion of Jupiter's moons. Now, that was the first time a speed was concluded. And if you go back to my old videos that I did about when I read Kings Dethroned, the first 3 chapters are dealing with Ole Romer and his failed methods to achieve this information. So please go back and check those out if you haven't. But these are all just a little bit of information, you know, that I'm trying to add on to this, John. I hope I didn't diverge it too much. But so yeah, what do you think about the changes of the speed over time? Is it just because it's erroneous to even try to measure it? Is that what the problem is?
That's what I would. That's why I dismissed it, because I did go down that road, and I remember that Ramirez. There was a number of different people through the centuries. I remember mapping it out a long time ago, and there was one guy more recent. I don't recall his name. He's pretty popular. I think he's a physicist from Australia. His name escapes me right now. That he combined it with the redshift and doing all kinds of stuff. Listen, like I just said, I nipped it in the bud with the 2-way and the 1-way speed of light and quantum mechanics. So I just, in fact, that was a pretty long. I had a lot of information on it. I just deleted it.
No, I hear you. Actually, and I just want to point out, I typed in speed of light over time, and livescience.com says Einstein's theory of special relativity sets of the speed of light at 186,000 miles per second, 300 million meters per second. Speed of light is constant, or so the textbooks say. But some scientists are exploring the possibility that this cosmic speed limit changes, a consequence of the nature of the vacuum of space. But I would actually go so far as to say that they don't know really exactly what they're doing based off of the information you just presented. If Einstein's relativity is the way he claimed it to be, then we would have no way of measuring the speed of light or the distances to these stars. And
Yes,
also
you got.
something I heard,
Yeah, yeah, yeah.
just quickly, something I heard earlier today by somebody is that if the speed of light has changed over time, then the measurements to the stars that they claim that they know would be skewed and varied over this entire time. The same with the sun. Originally, it was 3 million miles away with Aristophanes. Then it ended up being, I think it was 12 million miles away with Kepler, but he added a caveat and said, "But don't worry, science will find it anyways. It doesn't matter if it's 12 million." And
Yeah,
then,
but
of course, it just yeah.
sorry to interrupt. There's another problem too, uh,
Hmm.
that I just thought of. There's a paradox with the speed of light decreasing over time, um, and it has to do. I'm trying to recall this from many years ago. It has to do with the 1987 supernova. It has to do with that. Listen, like I said, I deleted my whole file on that.
Yeah.
So
Yeah.
I just want to bring that up. That's a player. I
Sure.
remember that being a serious player. So you're going to run into some problems with it decreasing. So
Yeah. Yeah. But, just to finish up what I was saying about the distance to the sun, all of their math that was used back with Copernicus, back with Kepler, and these are the two guys who really concretized these ideas. They're the ones who are putting forth this notion of a heliocentric universe, which back then that's all they had. The solar system was all that there was in Copernicus's mind, but all the math that he did was based off of I can't remember exactly. I think it was off the 3 million mile sun. Kepler changed it to 12, and the math was all based off of that. Now we're up to 93 million, which, funny enough, is the number of Thelema, but we won't get into that.
did you say did you say concretize?
That's correct, sir.
That's why we got together. I need to expand my vocabulary.
Well,
Concretize.
yeah.
I like it.
Well, I mean, that's what they did. They really, cemented that idea back then. They made it, as plausible as possible. I mean, these Jesuit priests, Freemasons, made it as plausible as possible to push onto the mainstream. And back then, we had 800 years of Ptolemy. For them to propose this system, it had to be well defined, and they did the work. I mean, when you look at the work these men do, I can't discard it. It is something. They took I mean, hell, Kepler even had to go kill Tycho Brahe to get his observations in order. And Tycho Brahe was doing a geocentric system, by
That's
the way.
right.
If you go look
Yeah.
at Brahe's system, so he had some of the best observations of the time out of all the astronomers. Tycho Brahe meets Kepler a couple weeks later, ends up dead with mercury poisoning,
So
and Kepler takes his
wait a
whole.
second. Wait a second. Are you accusing Kepler of murder?
I absolutely am, actually. And that's going to be on record. I'm
That,
serious. I really
did
think he
you
did.
did you concretize that?
Today I am. Today I am. But what I'm saying is the math is based off of these distances. For them to be able to assert these distances over time, we've had multiple distances to the sun, multiple distances to the star, multiple. And for anybody to think that what we are declaring as true today in the mainstream, for them to accept it as ultimate truth is folly. Because if you look back with a historical lens on scientific progression, or scientific in the sense of within the scientific community, we've been wrong 90% of the time.
Yeah, because it
You want
wasn't science to begin with.
Well, absolutely, we've covered that prior. But
Yeah.
what is declared in the mainstream is typically 90 to 95% wrong. And that's why real science is so valuable, because it
Exactly.
will find those errors. And I do give credit to that, you know. But this whole thing that I'm trying to share with people is science versus scientism. And this whole belief that science is the ultimate authority and what they are saying, and they even turn it into a noun. Science says this and science says that. And it's just complete folly because we're usually wrong about things. So I just want people to start thinking differently about this and question what the mainstream is saying. How else are we going to find better creative ideas out of this? You know. So, anyways, that was my bit for a moment. Let's go ahead and move into your next presentation on cosmic microwave background.
All
This
right.
is, and I will say, with what you're showing here is it's a very specific issues. So I encourage every single person who's listening to please go and do the research into the cosmic microwave background. We're going to be getting into it a little bit bigger down the road, but so that as a disclaimer, go ahead, John.
All right. Let me concretize the cosmic microwave background radiation. All right. From the Kobe Fierce and DMR, along with Penzias and Wilson discoveries, is the cosmic microwave background. But it's of the immediate background, the oceans and the water in the atmosphere. And I'm going to show you exactly how and why. So let's see. Let's put a cup of water in a microwave. What happens? Well, if it gets hot, it's an absorber. By definition, if it's an absorber, it's a powerful emitter. So let's have a look. We got the water molecules, right? We're going to be looking at two bonds here, the hydroxyl bond and the hydrogen bonds. So on the left over here, you got the hydrogen bond. These are intermolecular bonds in the water dimer, right? It's represented by dotted lines here. However, the hydroxyl bond, the intramolecular bond is here. All right? This bond right here is 100 times stronger than this bond here. That becomes critically important. The bond force constants, the hydroxyl versus the hydrogen, are the CMB whisperer. The water dimer in water vapor and condensed water acts like a simple harmonic oscillator. The energy in the hydroxyl bond, like I said, is 100 times stronger than the hydrogen bond. So, when looking at the emission of the water dimer, it will be equal to the ratio of the bond force constants, that's the hydroxyl versus the hydrogen, which is also related to temperature. So, okay, what temperature are we talking about here? Well, the Earth radiates roughly like the 300 Kelvin curve. Well, what is the Earth? The majority of the surface of the Earth, what is it? It's water, right? So when attaining 300K emissions, that's black body emissions of the oceans or the Earth, you then divide that ratio or divide by that ratio. And what is it? Drum roll. That's 3 Kelvin. Well, what's the official temperature of the cosmic microwave background radiation? It's 2.725. I mean, they're almost exactly the same. This should have, started raising red flags everywhere. So Kobe, go ahead.
Oh, I was just
Did you say
gonna
something?
add in. I had a thought about it. I hate to
Okay.
interrupt, but
No, go ahead.
don't they find it strange that the middle of the CMB matches up with our ecliptic? Is it the
Oh,
ecliptic or the equator that it matches up with?
yeah, that's not, you're going down the axis evil route, right?
Well, sure, yeah, but I mean, I do find it interesting that what it's showing as the most microwave emissions are coming from that center point, which aligns with. Is it our equator or is it the ecliptic that it's matching up on?
Yeah, you know what? Now that you say that, that is funny.
You see what I mean?
Yeah, I'm seeing it now.
So that is the hottest part on Earth. You know, anyways, just a random thought, and I hope to
No,
be
no,
getting
no.
into that stuff down
That,
the
that
road. But
was
let's,
that was good. Let me think about that. Bring that. Send me a message on that.
yeah, yeah, we'll talk about it. But go on.
Okay, so Kobe at 900 kilometers above the Earth, that's not that high. And yeah, right. Anyway, it had a shield protecting the horn from RF and thermal radiation, not microwave. Naturally, I'm going to show you a picture here in a minute. Have you heard the term diffraction before? You see, low frequency waves like radio and microwave diffract the most. So it's already protected from RF. We don't need to worry about that. But it's obviously it's not protected from microwave. So what's going to happen? Let's take a look. Here's Kobe DMR and Fierce. So what I want you to focus on here is this shield that goes around here. See, all the instruments are inside the shield. However, look what we got down here. You see all this down here? This is the Earth. This is all the oceans. What you have is the oceans emitting microwave radiation. What are they going to do? Well, it's going to come up here and diffract over the shield into the instruments. Bam, bam. It's gonna soon overwhelm this thing. And remember, like I said, the lower frequency, longer wavelength, those waves diffract the most. So they're going to be pounding this thing, man. Right?
Yeah.
All right. Oh, I had a special note here. The Kobe Fierce DMR horn was designed to operate from 30 to 3,000 gigahertz. There is no other horn in the history of man, including now 20 years later, that can match that fairy tale. It's an engineering impossibility. So
So
more
just
on
to,
Kobe.
yeah, just to
Go
be
ahead.
clear for our audience, what that horn is a protective material that will stop particular frequencies. And that one in particular that you just showed is not,
Yeah,
you're saying cannot be engineered?
yeah. This right here, not to cover that wide range of frequencies.
Okay.
But remember, this is just the shield. It's not the horn.
Oh, okay. What is the horn then for the audience?
These are not the. These are not the. This basically in here is the horn.
Oh, I see. I see. Okay.
But
The
this is the
instrumentation.
shield surrounding it because it doesn't. You'd contaminate it easily with thermal and RF, but they protected it from that. But they can't protect it from the microwaves diffracting. You see where I'm going with
Yeah,
this?
absolutely.
All right.
Yeah, I see it completely.
Yeah. So, but basically, there were three components to the CMB. You had Kobe, Fierce, DMR, you had WMAP, and then you had the Planck satellite. So we're going to talk about all of them here. We already went over Kobe. So
Okay, great.
WMAP. My goodness, people, look at the maps in the research papers. It gives a whole new meaning to Photoshop and scissors, right? This is from Smote. Look at, see, this is the galactic foreground. This is what we're trying to look through. But according to their story, the galactic foreground, you're trying to look through that to see out into space. So this is what you get. I mean, you're getting hammered right here by the galactic foreground. So what did they do? Well, they just snipped that thing out of there. So no Photoshop, we use scissors this time.
Yeah, they thought it was an error, wasn't it, in the first satellite,
No, no,
right?
no, no. They didn't think this was an error. They knew that I mean, everyone had to know you're going to get bombarded by the galactic foreground.
Okay, they got okay, I see what's happened here.
Now this
But
isn't
they thought it was wrong. Wasn't that the case?
no, this isn't the fine. Remember, this isn't the final take. This is in the research papers
Okay. It's so
that they
funny
put
they
in.
put
Yeah, yeah, yeah.
What did they
Yeah.
claim that graying out of it was? Just to ignore it, essentially, and
Well,
look at what else?
everyone knew it because as soon as you see this picture, yeah, that's the galactic foreground. We all know that. They all. Now, why did they leave this picture in there? I don't know.
Huh.
I can't tell you that. All I know is it's in their papers. That's where I found it.
Gotcha.
So they just cut it out. The heck with Photoshop. Now, like I said, this isn't the final draft of the WMAP. These are just in a long progression. There's about 30 or 40 of the, yeah, there might be even more. You know, it was a composite. I know you guys love that word. So the WMAP results are composites. So, but we're gonna chop its knees out from under it here in 1 second.
All right.
So there's so many holes in this WMAP, it's like a dartboard. Let's take one and annihilate it. All right. The units of measure for the anisotropies are in microkelvin. And the measure for the galactic foreground is in millikelvin. That is to say that the noise is 1,000 times stronger than the alleged signal. That's, you got this. This is big. By experiment and common sense, it is well known that if you have a signal that is 1,000 times weaker than the noise, you cannot remove that noise to extract the signal unless you have an a priori knowledge of the nature of the source and you can physically manipulate the source. Can we do that? No. So goodbye, WMAP. You're done for. This is the big one.
Yeah.
This is the big one right here. This one has the boat going over the edge.
Gotcha.
So the Planck satellite at L2, that's at 1.5 million kilometers from Earth. Yeah, right. However, this is pretty funny. So this satellite carried two 4K reference black bodies. They're comparators, high and low frequency. They're both encased in aluminum. But they ran into a problem. They couldn't keep the low frequency black bodies at 4K. They noted that the high frequency black body was good to go and was attached to the shield. So to keep the low frequency black body at thermal equilibrium, they decided to bolt it also to that same high frequency shield. Sounds good. What's the problem? Well, they used metal washers and screws. That creates a conduction path. Hitherto renders the black body no longer a black body. So then they compared the low frequency black body reference horn to the sky horn and got great results. They got a match because they're getting 0 from the black body reference horn and a match from the sky horn, which must be at 0 to get a match because there's no black body because of the conduction path, which is confirmed by no monopole signal at L2 from Planck. I mean, this is a monster. The best part of this, they unwittingly confirmed in one fell swoop that there is no cosmic microwave background and confirms that Kobe Fierce and DMR results were both overwhelmed by the giant microwave emitter, the oceans. Absolutely classic. Thanks. Bye-bye, Big Bang. Well, we didn't really need it anyway. Right? Oh, and this
and just before you go forward, John, for the audience, I'd like to just point out what a black body is. Now I'm going to read it off of Google here. A black body refers to an opaque object that emits thermal radiation. A perfect black body is one that absorbs all incoming light and does not reflect any. At room temperature, such an object would appear to be perfectly black. Now, they use these as reference tools for control.
Yep, they're comparators.
Am I correct in saying that? Yeah, they're comparating. Okay.
They're comparators, basically.
Yep. Exactly. So as you're saying, by putting those metal directly onto it, you're making a conduction path which completely skews the potential result that you may get from them.
No, it doesn't skew it. It pummels. It takes its whole entity away.
Well, it's fair enough. I guess that was too nice of a word, but you know what I mean.
Yeah. Let me concretize it. This is a fiasco. Right here.
Gotcha.
This isn't the only fiasco. We're going to get to a better one here in a moment. So let me concretize this. Then this. This was taken right from the Astrophysics Journal. This black body curve, right? They said that the thickness of this line is 400 times thicker than the error bars. That was one of their claims, right? So let's take a look at this. Let's have the audience take a look at this. My first question, why is this shifted to the right? Where's this data? And I don't know if anyone's noticed this. I want you to take a look at the x-axis, everyone. Okay, let's count. So we have 1, 2, 3, 4. Uh-oh. Where'd 4 go?
And this is in their published document, correct?
Yes. Yeah, I took it. This is from the Astrophysics Journal in 1996.
Wow.
Listen. If I would have handed in a graph in junior high general science, the teacher would have politely smiled, tore it up, and had me do it over again. We all know this, right?
Hell, it would have done that way in 7th grade.
Yeah. You can't. This is a joke.
How does stuff like that get through? It just doesn't make any sense.
Yeah.
It's ridiculous.
You asked me why before. I will not tread down that road.
We'll get there, though. We'll get there eventually, everyone, because these glaring problems that we see with it that John's really hammering out point to a larger issue concerning these, and we'll get into that in a future episode. But carry on, John.
Oh, but this isn't the last one. And according to their theory, how in the world are you getting a continuous black body spectrum from the universe? Is it in a box? And how are they getting a continuous black body curve from space? You only get them from solids. Is the universe, space, a solid? I don't know what more you want me to do here. I mean,
yeah, this is their major proof, quote unquote, of the Big Bang cosmology.
Well, but yeah, Big Bang. It's not a theory. They're just piling, extrapolations on extrapolations off
and
of
mathematical constructs and crazy ideas about what things are. And yeah, it's that's the thing a lot of people don't realize is most of what we hear in modern cosmology is mathematical extrapolations and these type of ideas piled together to give a materialist answer for the world. The Big Bang cosmology is essentially materialist in nature, and that is a philosophical position that they have taken. Now, naturalism is great. Methodological naturalism is fantastic for doing real science, but it should not be adopted as an ideology. And this is what we've been going over for all these other episodes.
Well, that's already been falsified.
Absolutely.
Materialism and realism has already been falsified. Quantum mechanics falsified.
Absolutely. So by virtue of that alone, the Big Bang cosmology is already erroneous. They are extrapolating something that happened 14 billion years ago. There's no evidence. There's no proof. And this is the closest thing they can get to some type of validation. And even these are pointing to a larger problem.
Well, this in Redshift. We're going to do one on Redshift too. That's going to.
Oh, absolutely. But you know what I mean. This is the principle covers this quite well. And we'll get into why these errors might exist, because we have another idea about why these quote unquote satellites, have all this information. But currently, if you take it on its own value, just, accept that they're real or whatnot, even their own data is pointing to a massive problem with their Big Bang cosmology. We're at the center.
Well, the Big Bang is a first law of thermodynamics violation to begin with. we don't even have to talk about quantum mechanics. It's a one lot violation. It's over. It's false. So their speculation off their just so story is baloney. Right there.
Absolutely. Absolutely. And like I said, it's all just there to reaffirm materialism. That's the entire point. They're trying to place an ideology out of a method.
Well, they're reaffirming falsification.
Absolutely. And it's erroneous. So hopefully we can shake the spell of materialism on humanity. I think for us to really move forward as humanity, we need to be able to see it for what it is. It is religion, as you have pointed out. It is a philosophical construct. It's a paradigm, and it isn't real. It's erroneous. It's thinking about reality in the wrong way, which will harm humanity essentially. So, speaking of leading into that, I would like you to, if you're going into that next, that quote from that professor.
Oh, that's a whole article. I just took a part out of it. If you could put that in the description, I think I sent you the link.
Well,
right?
actually, I'd like to read it if you're not going to.
Oh, go ahead.
Here, let me pull it up.
You can read it.
Well, actually, yeah, there it is. So I'm going to read this from, what is this gentleman's name? Professor
Singham,
Mano Singham. And let me pull up his information because he has some other stuff that is, here we go. There's the article.
Yeah, this is a real eye opener.
Okay, so I want everybody to pay attention to this. This individual, I'm looking into him currently. He's very much against the way current academia works concerning, the way that we pump out information. So let me read a couple clips. So I used to wonder whether most students were like Jamal, secretly rejecting everything I said, but acting otherwise in order to get good grades. But not many students can successfully maintain that level of dualistic thinking over a long period of time. I finally concluded that most students believe me because they trust me. They feel that I have their best interests at heart and that I would not deliberately deceive them by teaching them things that I myself did not believe. They also trust the institution that awarded me a physics PhD and the university and the physics department that hired me and allowed me to teach them. And I use that trust effectively to brainwash them. We who teach introductory physics have to acknowledge, if we are honest with ourselves, that our teaching methods are primarily those of propaganda. We appeal without demonstration to evidence that supports our position. We only introduce arguments or evidence that supports the currently accepted theories and omit or gloss over any evidence to the contrary. We give short shrift to alternative ideas, introducing them only in order to promptly demolish them, again by appealing to undemonstrated counter evidence. We drop the names of famous scientists and Nobel Prize winners to show that we are solidly on the side of the scientific establishment. All of this is designed to demonstrate the inevitability of the ideas we currently hold, so that if students reject what we say, we are declaring themselves to be unreasoning and illogical, unworthy of being considered as modern thinking people. Of course, we do all this with the best intentions and complete sincerity. I have good reasons for employing propaganda techniques to achieve belief. So I, like all my colleagues, teach the way I do because I have little choice. But it is brainwashing nonetheless. When the dust settles, what I am asking my students to do is to accept what I say because I, as an accredited representative of my discipline, profession, and academia, say it. All the reason, logic, and evidence that I use simply disguise the fact that the students are not yet in a position to sift and weigh the evidence and arrive at their own conclusions. Wow. Now, this is exactly what this entire series is about.
Yeah.
It is so unfortunate to see, but there are people who are under a spell which could be easily described as the brainwashing. They have an authority complex where they'll accept things based off, as he pointed out in this article here, because they trust the institutions, they trust the people who are doing it. And the problem is we are so many generations down this path that even the ones with, as he said at the end there, with good intentions, are still employing these techniques and tactics. And most of them are probably unaware of it, as he also points out. So we just need to shine a light on this. Humanity needs to be thinking about this more critically and stop accepting pop science. Just, people watch that on their Facebook feeds or, their news feeds or whatever. They see a pop science article come up. Kepler just discovered 1,032 planets in one fell swoop. And they're like, wow, that's so cool. We're going to go to space someday. And most people accept it as gospel. And I'm not talking about some of the people who are more scientifically literate and people who might be listening who disagree with me. It's a spectrum, and I'm generalizing. But unfortunately, there is a cult mentality. There is this consensus reality where a person who's in that paradigm doesn't even know they're in that paradigm. And they truly are not able to think for themselves, unfortunately. Even the smartest ones I have met, they just regurgitate whatever Rational Wiki, Metabunk, Snopes, or even Wikipedia itself says. That is the epitome of consensus reality and the epitome of not being able to think for yourself. And how that happens is exactly how this professor just explained it. So I really appreciate you bringing that to my attention, John. I'll get off my soapbox, but that's the whole reason why we're doing this.
Now,
in my opinion,
I thought you concretized that very well.
Now you're overusing it. It's going to lose its effectiveness. But yeah, I am just so grateful that we're able to do these presentations, and of course you have detractors and people who disagree, and you've been very avid in the comments and responses, and I really appreciate that, keeping people engaged. So because we do have honestly, this is heresy. What we are saying, we are questioning the priests, and we are trying to point out the gospel of their materialism church, and what we are modern heretics.
Yeah, well, this is religion. This is what religion does, right?
Absolutely.
Right? We appeal without demonstration to evidence that supports our position. Undemonstrated propaganda techniques, brainwashing, just because we say it. I'm sorry. Yeah. I live in Missouri now. You have to show me.
This is taking the information on high, prostrating yourself at the feet of these brand new priests in white coats. And yes, I'm being hyperbolic and dramatic, but it is true when you really sit down and look at what's been happening. This is the nature of humanity, though. Humans have a tendency to trust authority. This is the way that we're conditioned and we're bred.
Yeah.
And that's, of course, on purpose. If you look at the modern education system, it was built after a Fabian socialist idea in the early 1900s, taking it from portions of Germany and Russia in order to create a workforce that was only capable of performing the industrial work that was going on at the time. They were teaching you how to not think for yourself and how to only follow orders. That's essentially what they were creating back then, obedient workers. And this system has gotten stronger and better and more powerful all the way up through even high academia. This is what they're doing. They've created the system on purpose for an immense level of population control. You control the axioms of the population, you control their behavior and how they think and how they act. And then you train them to not question things, you got a recipe for disaster.
Yeah.
So we just have to see this for what it is. And I want to, for someone in the audience, I want to just retouch on this. John, could you define science for me? What is real science? Once again, we'll touch base. I know we did it over in the first episode, but
Sure, sure. Science
I
is
want to
nothing
make
more.
clear. Yeah.
Yeah, I'm going to make it clear. Science is nothing more than its method. It's only a method of inquiry. That's all it is. It's not an entity. It's not a result. It doesn't have vocal cords. It doesn't say, run, jump, swim, or do the hokey pokey. It's just the method of inquiry. An important method, but it's just a method.
Well, they also say in the definition that science can be defined also as the body of work that the method has provided.
Yeah, well, that's what if you're using the method and it produces the body of work, what's first? What's the necessary condition? The method.
Yeah, the method. Absolutely.
The
If you
the
boil it down
results,
to the brass tacks, yeah, absolutely.
yeah, the results are merely the consequent of the necessary antecedent, the method.
Sure. So it's not, and this is where the problem comes in today is people view it as a monolith. They treat it into a noun. Science says this.
Yeah.
Science doesn't say anything. It's
That'll
a
give me an
process.
epileptic seizure.
Oh, I know. I've accidentally said it like that around you before. I know. And a quick funny story. The first time I met John here, I was in a Robert Bassano hangout. John didn't know me, and likewise, I didn't know him. And when I jumped in there, I was talking to Robert about a conversation I had with Jaron. And John cut me off and he said, "Wait a second. I need you to tell Jaron something for me." And I was like, "What's that?" And he goes, "Tell him to stop talking like science is a person. Science doesn't say shit."
Did I
And,
say that exact thing?
pretty close. Pretty close. You were pretty assertive about it, and I thought it was great because you're dead on and you're right. And honestly, no disrespect, Jaron, he does say it like that quite a lot. And
Listen, Jaron's not the only one. Jaron, and how many people are on the earth currently?
7.8 billion, they claim.
All right, well, 7.7 along with it. You know what? Sometimes I catch myself doing it. You know,
Oh,
that's rare.
absolutely.
That's rare nowadays. But I used to do it, and then I said, "Oh my!" So, yeah, he's not the only one, but it drives me nuts.
Yeah, well, it's something that we have socially been conditioned to, you know,
Sure,
speak of it like, and
right?
that, and hence, once again, why I'm doing these shows, because these are serious topics. We're talking about understanding the world around us, and when people are taking information on high and they're not really understanding what it means, they're just regurgitating it, we have a problem. That's groupthink. That's Orwellian.
Yeah,
I mean,
but then,
we're on the verge of a scientific dictatorship in that regard. I mean,
yeah,
Aldous
yeah, but
Huxley and
what?
C.S. Lewis were right.
Yeah, but what happens then is they have no depth. So as soon as you start rubbing even formica deep underneath it, it's like a house of cards. It falls apart. So
Yeah.
so that's the problem with that. Now, if they go on without getting challenged, like the majority of people do, then yeah, then they quote unquote have accomplished their mission. But as long as I'm out
Yeah.
here, you're getting challenged.
And that's what I'm talking about. Yeah, I've really been looking into, C.S. Lewis's work, where, I mean, C.S. Lewis coined the term scientism. And then you have Aldous Huxley, who wrote a fantastic book about the dangers of a scientific dictatorship. And what I find really ironic is both C.S. Lewis and Aldous Huxley died on November 22nd, 1962. Or was it 63? The same day that John F. Kennedy was shot. So they claim. Now, that is kind of startling because these are three men who had influence, who were opposed to this particular type of direction that the Nazis from Project Paperclip have moved us into. So if anybody in the audience is unfamiliar with what happened with Project Paperclip and the thousands of Nazi scientists and SS officers that we littered all across the military industrial complex, who created NASA with a Satanist named Jack Parsons. If you're unaware of that, then please get to work and try to understand the subtleties of what we're looking at, the in between on all this. If anyone thinks that 10,000 some odd scientists and engineers who were from Germany after what we did to that country, so to speak, if you think these men had Americans' best interest at heart, you're sadly mistaken. So personally, I think there's a connection with all this. I don't want to get all conspiratorial, but I really do think that it's possible that the Nazis didn't lose and that they just came up with a different idea about how to go forward. So publicly, you make it out that they lost. And if you think about it, only 24 Nazis were actually prosecuted under the Nuremberg trials. A lot of people don't realize that. 24 people is all that were prosecuted during those trials. So we had plenty that went to South America through the Vatican rat lines. This was a Jesuit operation from the get-go. So personally, I think that America has turned into something different. And if you look at what Mussolini had said about what the definition of fascism is the corporations working hand in hand with the government. And what we see the closest connection to is the military-industrial complex. And what's part of that? NASA. What's part of that? JPL, Raytheon. These are companies that are owned. A lot of people don't know this either. After the war, World War II, JPL, which was called Jack Parsons Laboratory, worked with the Army since 1938. They ended up taking over the company fully. The American government did. And they changed it to Jet Propulsion Labs. So people need to realize that interaction of the military-industrial complex and our government, they do not have the best interests of the population. Military-industrial complex is there to protect their knowledge, protect their information for national security reasons. So I think that if this Earth is any different than what they've told us, or if space is something different than what they're telling us, I think it's actually pretty likely, pretty possible. If they went up there and checked out what we've been saying for 400 years, what Kepler thought, what Newton thought, what Copernicus thought, if they went up there and they realized it wasn't what we've been saying, do you think they're going to come back down here and tell us? For national security reasons, you can't break the paradigm. So I just want people to think about it differently. Sorry for my little rant there, but this is the way that I look at the situation. And I think we need to be a little bit more honest with ourselves about what humanity does to people, what humanity has done historically. These are not people that you can necessarily trust. You have to vet every single thing that comes out of there. And the more you vet NASA, the more you realize that there is something very different going on than what they told us. And that goes for the CMB and other, especially any satellite data. God knows what those machines really are. But anyway, sorry for the rant. I just wanted to get that on record, John. So let's see. The next presentation, you said you're going to be doing redshift, blue shift?
No, just redshift, man. No, I'm not doing blue shift.
Mm.
I don't like.
Okay, so we'll be covering the redshift situation.
I don't like things coming at me, man. I want to concretize redshift.
Well, concretize because their definition of redshift is you think is wrong. What is it going to be about exactly?
It's redshift. It's anomalous redshifts. So what they think
Gotcha.
is what they're extrapolating from is fairy tale. It's just like everything else.
Yeah. They see a little red in the sky and they immediately think it's the Big Bang exploding away from us, etc., etc.
Yeah, we should do one on the Big Bang. It would take like 2 minutes. Evolution would take like 30 seconds, maybe shorter.
Well, sure.
Yeah, we'll add some more to that. We might get into some functional sequence complexity next week. It sounds scary, but it's not. It's really easy.
Concerning genetics?
Just Well, it's one small part of it. I mean, not only genetics. No.
Oh, okay. Well, great. Yeah, we'll definitely get into it. I kind of want to stay on the cosmology tip for the next couple shows. Definitely showing the redshift situation, and I might be able to put some information out myself because that's really all I'm doing here. Is like we need to question our cosmology. There is no reason for anybody to not think about this stuff and just accept what they're giving us. We have every right as a human being to explore the cosmos from our vantage point. And that's all that is. If you just accept one answer, you're closing the door on an infinite amount of possibilities. So, yeah, that's how I want to go forward. You got anything else to add to the show today?
No, I think that was plenty.
Yeah, I kind of went off on a couple tangents. All right, well, we'll go ahead and wind this down, and really appreciate what you're doing, man. The information's great, and the whole of it's even better. So, thank you very much, everybody, for listening. I appreciate all the support in the chat. And if anybody has any questions, please put them in the comments section. John has been great about responding to them, so definitely do that if you want. But thank you, everybody. Thank you, John, and you guys have a great night.